In the name of Almighty Allah, the most gracious, the most merciful. As Muhammad, peace be upon him, narrated, if anyone travels on a road in search of knowledge, Almighty Allah will cause him to travel on one of the roads of paradise. Hello everyone, this is your Dr. Tariq Masood. Thank you very much for watching my videos and your wonderful support to make this channel a grand success. We are a family, a partner. Please share and subscribe our channel if you haven't done so far. We as a team can work together to convert challenges into opportunities and opportunities into success stories. These success stories can be monetized into value addition in the world by large. Thank you very much for your precious time. Today I'm going to discuss my lecture number 6 on fluid catalytic cracking FCC unit, governing a pathway, delivering on commitment, differentiated performance, enabling profit optimization process, lecture number 6. Before my lecture, I used to read a Quranic verse. Qala Rabbi shrah li sadri wa yassir li amri wa halul uqdatam min lisani yafqahu qawli Allahumma Rabbi zidni ilm. O my Lord, open my chest and ease my tasks for me, and loose a knot from my tongue that they may understand my saying. Allahumma Rabbi zidni ilma. O Allah, advance me in my knowledge and true understanding. Okay, fluid catalytic cracking, lecture number 6, FCC unit of process of flow descriptions. Okay, key takeaway points from lecture number 6. Wet gas compressor and high pressure receiver, gas concentration recovery, gas concentration fractionations. Okay, these are the 3 topics we are going to discuss today. Okay, first topic, wet gas compressor and high pressure receiver. Okay, wet gas compressor and high pressure receiver. The gas concentration section of the FCC unit is substantially fed by 2 streams. First, vapors and hydrocarbon are liquid effluent from the main column overhead system. The liquid hydrocarbon product from main column receiver is brought to a pressure level of the gas concentration section by main column net overhead pump. Okay. It is a transfer to a primary absorber under a level and flow cascade loop, where it is again brought into contact with the gas main column overhead product. However, at substantially higher pressure than in the main column overhead system. The liquid bottom product of the primary absorber enriched with LPG recovered from the vapor phase is pumped by means of a primary absorber, rich oil pump under a level controller to the inlet of high pressure condenser. The vapor product from main column receiver is compressed by wet gas compressor to the pressure level of the gas concentration section. The compressor is designed as a 2-stage centrifugal compressor. On the suction side of the wet gas compressor, the vapor is directed to a compressor suction drum where intended a liquid separate from the hydrocarbon gas. The liquid, a mixture of the hydrocarbon and sour water, is pumped by a compressor suction drum pump and a transfer to a water injection point upstream main column condenser in on and off service. Okay, the hydrocarbon gas is fed to the first stage under a pressure control, which is picked up from the main column overhead system. The gas discharge from the first stage is cooled in a compressor interstage cooler and engaged cooling water in a compressor interstage trim cooler. Similar to the main column condenser, wash water is injected, flow control at the inlet to wash out any corrosive components. Cold condensate, steeped sour water from unit is used as injection water. The condensate obtained is separate in the compressor interstage suction drum and a pumped level control through LCV by compressor interstage condenser pump to the inlet of the high pressure condenser. The gas phase from the compressor interstage suction drum is compressed to the second stage of a wet gas compressor The discharged gas is combined with overhead vapors from steeper and the liquid from primary absorber, a rich oil pump, and compressor interstage cooler. The mixed phase steam is cooled in a high pressure condenser and engaged a cooling water in a high pressure trim condenser and are routed to high pressure receiver. Similar to main column reflux drum, the high pressure receiver separates the incoming steam into gas, liquid, and water phase. The water collecting in the water boot is discharged a level controller through LIC as wash water to a main column condenser. The liquid hydrocarbons are pumped by high pressure receiver, a pump to steeper feed exchangers in the fractionation part of the gas concentration section. The liquid is withdrawn from the receiver under control of level and flow cascade control loop system. Okay, gas concentration recovery. Okay, gas concentration recovery. The primary absorber is equipped with a 40 valve strip as the gas from the main column receiver passes through the column from bottom to top. Valuable allied product such as LPG are recovered using unstabilized naphtha from a main column overhead system and debutanizer spot. Unstabilized naphtha is sent to train 9 where debutanizers bottom is sent flow control to the top of the column after cooling in steeper feed exchanges against steeper feed in debutanizer's bottom recycle cooler. Okay. Debutanizer bottom recycle trim cooler against cooling water. The recycled gasoline from the debutanizers can be adjusted to increase C3 C4 recoveries. However, the caution must be exercised to avoid a liquid flooding at high throughputs. Removal of the heat of the absorption is accomplished in exchange with cooling water by primary absorber lower intercooler and a primary absorber upper intercooler. The liquid pump round is maintained by primary absorber lower intercooler pump and a primary absorber upper intercooler. The bottom product is returned a level control through LIC by primary absorber rich oil pump to the inlet of high pressure condenser. The overhead gas is routed to a sponge absorber. The sponge absorber variable components are mainly C5 and C3 C4 still present in the light gas are largely absorbed using circulating LCU as an absorber. The lean LCU is fed through FIC on the top of the packing material, the absorber, and routed counter current to the upflowing gas stream. Rich LCU leaves the bottom of the absorber level controller. The gas exit at the sponge absorber. Top lean gas is cooled against cooling water in a lean gas cooler and routed to a lean gas knockout drum. Any condensate obtained in the knockout drum is sent to return line of rich LCU and routed to a main column. Has to be drained manually. Substream of the gaseous effluent of the lean gas knockout drum is routed a flow control to the reactor arises as a lift gas. Okay. The other portion of the lean gas flows to the gas amine absorber. In this column, the hydrogen sulfide, H2S, and carbon dioxide, CO2, or load of the gas is removed using amine solution as the absorbent. The lean amine solution is fed to absorber top tray number 1, flow control through FSC from a unit. Amine treatment across battery limit. The rich amine is withdrawn from the bottom under a level control and returned to other units amine treatment over a battery limit. The part of the suite of gas is routed to a purge gas drain or pot and used as a purge gas for the pressure pickup points, so-called DG points or DG dried gas as the reactor. The remainder is a fed pressure control to other units amine treatment across battery limiter for the fuel gas network. The drained liquid from the HCDN skims a nozzle at the gas amine absorber, and from the level instrument is collected in an interface pod. After separation of the hydrocarbon phase from the amine solutions phase, the vessel is drained to amine or some tank and light HC drain drum. Amine sump pump stops automatically on high and low liquid level in the tank. The amine solutions is pumped to a unit for regeneration purposes. Okay. Next is a gas concentration fractionation. Okay. Our next topic, gas concentration fractionation. Okay. High pressure receiver, a pump, a discharge a liquid hydrocarbon on a level and flow cascade loop, control to the fractionation are part of the gas concentration section. They are heated in exchange with debutanizer's bottom in steeper feed exchange and are routed to a top tray number 1 of steamer. In the 36 valve tray of the steamer, hydrogen sulfide and light hydrocarbon, that is C1 and C2, are stripped off. Bottoms are evaporated by heat input in exchange with debutanizer. Bottoms in steeper flow control of a low pressure steam is controlled in a cascade with ratio steeper feed control. The steeper overhead gas are routed back to the inlet of the high pressure condenser. The steeper bottom product withdrawn on the level flow control and heated engaged LCO in the debutanizer feed exchange before being fed to a tray 21 of the debutanizer. Okay, the debutanizer is equipped with 40 valve trays. It spilled the steeper bottom into LPG and a gasoline fraction. The vapor pressure of the stabilizers, a gasoline fraction, is adjusted by the debutanizer pressure and temperature. The debutanizer boiler is operated with HCO as the heating medium. The overhead product obtained in the debutanizers is LPG with major concentrations of olefins. The overhead vapors discharge under a pressure control (PIC) and are completely condensed in debutanizer condenser. And in exchange with cooling water in debutanizer trim condensers, the pressure controller controls the vapors flow to the condenser. The pressure differential controller, that is a PDIC in the hot vapor line, keeps receiver pressure from dropping too low by bypassing some vapors. This keeps a PV in range. The intent water is separated from the hydrocarbon in the water boot. When required, the water is strained manually to the inlet of the high pressure condenser. The control point for the overhead product is the level controller on the receiver. This control gives the set point for the net overhead product control to maintain the level of the receiver. The temperature controller TIC on a tray 10 gives the set point for the reflex flow controller. The net overhead product is pumped by debutanizer's overhead pump to other unit in order to maintain C3, C4 Marax after cooling engaged cooling water in the debutanizer and net overhead cooler. The bottom product from the debutanizer is consist light and intermediate naphtha. Okay, as mentioned in my earlier slide, the bottom product for the debutanizers consists of light and intermediate naphtha. It is first used as a heating medium for steeper reboiler. Downstream, the heat exchange the steam is spilled up. One substeam is routed back to a primary absorber. As absorbent in advance, it is used as the heating medium in steeper feed exchange under a spilled range temperature control of the bypass steams. The steam is further cooled in debotonizer bottom recycle cooler and engaged a cooling water in debotonizer bottom recycle a trim cooler. Debotonizer bottom recycle pump transports the steam under flow controls back to the top tray number 1 of the primary absorber. The other substream of the light and intermediate naphtha from steeper reboiler exchanger is directed to naphtha splitter under a cascade control loop of flow and level in the debotonizers. Before being fed to column, it is heated against a naphtha splitter, bottoms a naphtha split feed, bottoms exchange. The naphtha splitter is equipped with a 24 valve trace. It serves to fractionate the bottom steam from the debotonizer to a light naphtha as overhead and intermediate naphtha as a bottom product. Two boiler provides a heat input to the column. The naphtha splitter, a lower reboiler, is heated with HCO, while a naphtha splitter upper reboiler is heated with LCO. The bottom product of the naphtha splitter, intermediate naphtha, is pumped by naphtha splitter bottom pump. It is cooled against naphtha splitter feed in naphtha splitter feed bottom exchange. Flow is level controlled and is combined. Okay, the bottom product from naphtha splitter, intermediate naphtha, is pumped by a naphtha splitter bottom pump. It is a cooled engaged a naphtha splitter feed in naphtha splitter feed bottom exchange. Flow is level control and is combined with heavy naphtha steam from heavy naphtha product pump of the main column. The overhead product of the naphtha splitter is light naphtha. The vapor discharge under pressure control and are completely condensed in naphtha splitter condenser. The pressure controller controls the vapors flow to the condenser. The pressure differential controller in the hot vapor line keeps the receiver pressure from vapor are cooled in a naphtha splitter receiver. The control point from the overhead product is the level control on the receiver. This control gives the set point for the net overhead product control by using the FCC to maintain the level of the receiver. The temperature control on the vapor line gives the set point for the reflex flow control. The net overhead product is pumped by naphtha splitter overhead pump to other unit for gasoline barracks after cooling engaged cooling water in naphtha splitter net overhead cooler. Okay, this was my last slide. Now we are going to conclude today's lecture. What we discussed today? Today we have discussed wet gas compressor and high pressure receiver, the gas concentration recovery and gas concentration fractionation. My next topic will be FCC unit major equipment, their functions and purposes. These are a few references. Okay. Please do not hesitate to submit your feedback, comments, t.masood.here@path.edu. Thank you very much for your patience.